Hello children, now let us see radius of curvature. Consider a curve PQ. It can be assumed to be made of several small arcs. At any point, there will be a circle whose arc matches with arc at that point. So radius of that circle will be called as radius of curvature at that particular point. If the equation of trajectory of a particle is given, we can find the radius of curvature at a given point by the formula r is equal to 1 plus dy by dx whole square whole to the power 3 by 2 upon mod d square by upon dx square. First, we need to find out dy by dx and d square by dx square at that particular point and then put in this formula. Let us see one question based on this. Equation of trajectory of a particle is given by y is equal to under root 3x minus 2x square, where x and y are in meters. Find the radius of curvature of the path at its peak point. Take g is equal to 10 meter per second square. By just looking at this equation, we can say that this is equation of parabola. Consider a particle is projected with initial velocity u at an angle theta with the horizontal. It reaches a maximum point P and then comes down. So its path is parabolic. Now coordinates of point P will be r by 2 h maximum. That means we have to calculate its range and maximum height. So compare the given equation of trajectory y is equal to root 3x minus 2x square with the equation of trajectory of parabola as y is equal to x tan theta minus gx square upon 2 square cos square theta. So we will get theta is equal to 60 degrees and u is equal to root 10 meter per second. So range r is equal to u square sine 2 theta upon g. Take g is equal to 10 meter per second square. So range r is equal to root 3 by 2 meter. Maximum height is equal to u square sine square theta upon 2g. So maximum height is equal to 3 by 8 meter. So coordinates of P will be r by 2 comma h max, and that will be root 3 by 4 comma 3 by 8. Now given the equation of trajectory is y is equal to root 3x minus 2x square. So dy by dx is equal to root 3 minus 4x. dy by dx at P is equal to, put x is equal to root 3 by 4. So dy by dx at P is equal to 0. That is correct. Slope at the peak point is 0. D square y by dx square from here will be minus 4. That is constant. So radius of curvature at point P will be given by the formula Rp is equal to 1 plus dy by dx whole square whole to the power 3 by 2 upon mod d square y upon dx square. dy by dx is equal to 0. So Rp is equal to 1 plus 0 whole to power 3 by 2 upon mod of minus 4. Mod of minus 4 is 4. So radius of curvature at point P is equal to 1 by 4 and that is 0.25 meter. Now let us understand circular turnings. Consider a vehicle of mass m is moving on this circular road with speed v. This is top view. External forces working on this vehicle are its weight mg that works vertically downwards. Normal reaction applied by the road works vertically upwards. They balance each other. Since the vehicle is taking a turn, so its tires have a tendency to skid radially outwards. So friction force will be applied by the road that will work radially inwards. This is a static friction which is self-adjustable. This provides necessary centripetal force to take a turn. So we can say that friction force Fs is equal to centripetal force mv square by r. Magnitude of this friction force will be equal to mu s into n, where n is equal to mg. This is maximum friction force. It cannot be greater than this. So Fs is less than or equal to mu s into mg. Put Fs is equal to mv square by r. So we get v square is less than or equal to mu s into rg. From this equation, v is less than or equal to under root mu s into rg and mu s is greater than or equal to v square by rg. This is speed limit. Vehicle cannot have speed more than under root mu s into rg. And coefficient of static friction between the tires and the road should be greater than or equal to v square by rg. Let us understand banking of the roads. If the speed of the vehicle is more than this and turns are sharp, as usually happens on hill roads, then friction force alone is not sufficient to stop the tires of the vehicles from skidding. There must be some other provision, and that provision is banking of the roads. In banking of the roads, outer part of the road is somewhat lifted as compared to inner part of the road, so that vehicles moving on the circular path looks little bit tilted towards the center. Let's say theta is the angle of banking. That means road is at an angle theta with the horizontal. In this case, normal reaction applied by the road N will be at an angle theta with the vertical. We can resolve N into two components, vertical and horizontal. Vertical component will be N cos theta, which will be equal to weight of the vehicle mg. Horizontal component N sin theta will provide necessary centripetal force to take a turn. That means N sin theta is equal to mv square by r and N cos theta is equal to mg. If we divide equation 1 by 2, we get tan theta is equal to v square by rg. Here theta depends on speed of the vehicle and radius of the circular path. So v square is equal to rg tan theta, or v is equal to under root rg tan theta. This is speed limit of the vehicle. If speed of the vehicle is little bit more than this, then static friction force, which is self-adjustable, will come into picture. But if the speed is much higher than this, then even a maximum friction force will not be able to stop the skidding of the tires of the vehicle. Now let us understand centrifugal force. Suppose a man is sitting inside a cabin. A heavy box of mass m is also kept in the cabin at a distance r from the center. This cabin is rotating with constant angular velocity omega about z-axis, which is passing through center of the cabin. There is sufficient friction force between the floor of the cabin and the box so that box doesn't slide on the floor while rotating. We will observe motion of this box in inertial and non-inertial reference frames. First, in inertial reference frame. A person who is standing outside of the cabin will see both man and the box rotating with constant angular velocity omega. Forces acting on the box in this case will be its weight that works vertically downwards. Normal reaction by the floor which works vertically upwards. Since this box has a tendency to slide radially outwards while rotating, so friction force on it will work radially inwards. This is static friction force, which is self-adjustable. This will provide necessary centripetal force for rotation. So Fs is equal to mr omega square. Let us observe motion of this box in non-inertial reference frame. The person who is sitting inside the cabin will see this box still, not moving, though there is net force acting towards the center. Since this box is not moving, that means there must be a force which is equal in magnitude and opposite in direction, that is working radially outwards. This pseudo force is called as centrifugal force. It is equal in magnitude with centripetal force and opposite in direction. So centrifugal force is equal to minus mr omega square. There are a couple of conclusions we can draw from it. First, if we are working in non-inertial reference frame, then there is a need to imagine pseudo force if the particle is at rest in a uniformly rotating frame. And if we are working in inertial frame, then there is no need to imagine any pseudo force. Let us understand Coriolis forces. We may have to assume other pseudo forces if we are working with non-inertial reference frame. Such pseudo forces are called as Coriolis forces. Coriolis force is perpendicular to velocity of the particle and also perpendicular to axis of rotation of the reference frame. Now let us understand effect of Earth's rotation on apparent weight. Suppose this is Earth, which is rotating with constant angular speed omega about its axis that passes through north-south poles. There is a place P on Earth's surface whose latitude is phi and co-latitude is theta. At this place, there is a room in which a bob is attached with a string and a string is hanged from the ceiling. Bob is in a state of equilibrium. This room itself is rotating on a circular path of radius small r. Capital R is the radius of the Earth. If we see from Earth's reference frame, which itself is rotating with constant angular speed omega, Bob is in the state of equilibrium. That means we can assume there is a pseudo force working on the bob which is radially outwards. This pseudo force is centrifugal force. Its magnitude is mr omega square. Other two forces working on the bob is tension in the string, that is T, and weight of the bob, that is working towards center of the earth. It is mg. Since bob is in the state of equilibrium, that means there should not be any resultant force working on the bob. So resultant of mg, mr omega square and T should be 0. Alternatively, we can say that resultant of mg and mr omega square should be equal and opposite to T. So let us find out resultant of mg and mr omega square. These are two vectors. Angle between them is 90 degree plus theta, and the resultant is given by under root a square plus b square plus 2ab cos theta. So it will be under root mg whole square plus m small r omega square whole square plus 2mg into mr omega square into cos 90 plus theta. Now, in this right angle triangle, sine theta is equal to small r upon capital R. So, small r is equal to capital R sine theta. Put small r is equal to capital R sine theta here. So, we get resultant is equal to m under root g square minus omega square r sine square theta into 2g minus omega square r. Let us say this part inside under root is equal to g dash. So resultant is equal to mg dash, where g dash is equal to under root g square minus omega square r sine square theta into 2g minus omega square r. G dash will be different at different places on the surface of the earth. It depends on co-latitude theta. Let us consider two cases, when theta is equal to 0 or 180 and when theta is equal to 90 degrees. When theta is equal to 0 or 180, place will be at North Pole or South Pole. So this part will be equal to 0. So G dash is equal to G. That means mg dash is equal to mg. mg dash is called as apparent weight of the body. So in this case, apparent weight is equal to true weight of the body. When theta is equal to 90 degrees, that means at equator, g dash is equal to under root g square minus sine theta is equal to sine 90, that is 1. So g dash is equal to g minus omega square r. Apparent weight of the body mg dash is equal to mg minus m omega square r. So apparent weight of the body will be minimum at equator and maximum at poles. Let us solve a couple of questions based on circular motion. First question, a hemispherical bowl of radius r is rotating about its axis of symmetry, which is kept vertical. A small ball kept in the bowl rotates with the bowl without slipping on its surface. If the surface of the bowl is smooth and the angle made by the radius through the ball with the vertical is alpha, find the angular speed at which bowl is rotating. This is hemispherical bowl, which is rotating about vertical axis with constant angular velocity omega. This is a small ball which keeps on rotating along with the bowl. This is rotating on a circle of radius small r. This angle is given as alpha. Capital R is the radius of the bow. So in right angle triangle OAP, sin alpha is equal to small r upon capital R, or small r is equal to capital R sin alpha. This is equation number 1. We can draw FBD of the ball. mg is its weight that works vertically downwards. N is the normal reaction applied by the surface of the bow. This angle is alpha. So N can be resolved into two components, one vertical, another horizontal. Vertical component will be N cos alpha and horizontal component will be N sin alpha. Vertical component N cos alpha will balance mg. Horizontal component N sin alpha will provide necessary centripetal force. So N sin alpha is equal to centripetal force mv square by r. Put v is equal to r omega. So N sin alpha is equal to mr omega square. This is equation number 2. And N cos alpha is equal to mg. This is equation number 3. From equation number 1, put small r is equal to capital R sin alpha in equation number 2. So N sin alpha is equal to m capital R sin alpha omega square, or N is equal to m capital R omega square. Put the value of N in equation number 3. So m capital R omega square cos alpha is equal to mg, or omega square is equal to g upon r cos alpha, or omega is equal to under root g upon r cos alpha. Second question, a body weighs 98 Newton on a spring balance at the North Pole. What will be its weight recorded on the same scale if it is shifted to the equator? Use G is equal to gm upon r square, and that is equal to 9.8 meter per second square, and the radius of the earth r is equal to 6400 kilometer. We know that at poles, apparent weight of the body is same as its true weight. So 98 Newton is equal to mg. Given G is equal to 9.8 meter per second square. So mass of the body m is equal to 10 kg. When the body is shifted at equator, apparent weight of the body is equal to mg dash, and that is equal to mg minus mr omega square, where r is radius of the earth and omega is equal to 2 pi by t. T is the time period of the earth, that means the time it takes to make a complete revolution, and that is 24 hours into 60 minutes into 60 seconds. So omega is equal to 7.27 into 10 to the power minus 5 radian per second. So mg dash is equal to mg minus mr omega square. R is given as 6400 kilometer, and that is 6400 into 10 to the power 3 meter. So mg dash is calculated as 97.662 Newton. In the next video, we will see circular motion in vertical plane. If you have a question, you can ask me on my Discord server. If you have not subscribed my channel yet, please do so.